Section 5.2, Sum and Difference Formulas, Part 3 of the notes. In this part of the notes, we're going to focus on being given certain information about angles alpha and beta, and then finding a sum or a difference using alpha and beta. Example 7, find exact values using sum and difference formulas. So we're going to suppose that sine of alpha is equal to 4/5 for a quadrant 2 angle alpha, and sine of beta is equal to 1/2 for a quadrant 1 angle beta. We're going to start by finding the exact value of cosine of alpha. Anytime a problem gives you sine or cosine of an angle equals a fraction and then tells you which quadrant it's in, I want you to make sure that you draw a picture. So let's start with drawing a picture that uses the information sine of alpha equals 4/5 and it's in quadrant 2. So first of all, I drew my triangle in quadrant 2. This is where alpha is. It's my reference angle. I know that sine is opposite over hypotenuse, so I'm going to label the opposite side of my triangle as 4, and the hypotenuse is 5. Now, in order to find cosine of alpha, I'm going to need to know what x is. So using Pythagorean theorem, or maybe you can just look at it and you might know what it is already, we're going to solve for x. So remember, we have Pythagorean triples, and the one we should definitely know is the 3, 4, 5 triangle. So anytime you have a side of 4 and a hypotenuse of 5, we know the other one's going to be 3. I labeled this as -3 because we're in quadrant 2, and cosine is negative in quadrant 2. So we know that cosine of alpha is equal to -3/5. Next, we have all the same information, but we're going to find cosine of beta this time. So we know sine of beta is equal to 1/2, and it's in quadrant 1. So let's draw that. So here's my angle beta. Sine is opposite over hypotenuse, so I'm going to label my opposite side as 1, and my hypotenuse is 2. And then we need to solve for the third side. Again, we can use Pythagorean theorem because we have a right triangle. We're in quadrant 1, so all of our values here are positive. So we get that cosine of beta is equal to √3/2. Now that we have found cosine of alpha and cosine of beta, we are going to find cosine of alpha plus beta. So here's what we know so far. We got our 2 sine values from the problem, and then the 2 cosine values we just worked to find. So we're going to use our sum cosine equation. And we're going to plug in what we know for each of those parts. Multiply our numerators and denominators. And then rewrite as one fraction. The last part to example 7, we're going to find sine of alpha plus beta. So again, we know everything in green, and we're just going to plug those things into our sum formula for sine.